Hi everyone, this is Purnima Mahalingam and we are watching video lecture series on solar and wind energy. Today in this video, we are going to discuss about solar PV application systems in solar resources. In this presentations, we explore how the solar energy power diverse applications is a global PV capacity in suspense of 1.5 tegawatts by the end of 2023. Solar now contribute about 4.9% of global electricity, highlighting its growth importance. Okay, this is what an application of solar systems. Now coming to the understanding the solar cells. What is an understanding of solar resources? Here comes first thing is solar irradiance. So the power per unit area from the sun. And the global horizontal irradiance, GHI, that is what is global horizontal irradiance. And the total solar energy on a horizontal surface, the total solar energy on the horizontal surface. And direct normal irradiance, DNA, the energy from direct sunlight, crucial for concentric sols. Okay. The solar irradiance varies significant based on latitude, time of day by year, and weather. So clouds can replace GHT by up to about 90% impact energy. Okay. For instance, Northern Europe sees around 1,000 kilowatt per hour per meter square per year, while desert exceeds 2,200 kilowatt hour per meter per year. So this is what are solar resources available. So we can see the where the maximum solar resources are available. Now coming to the core photovoltaic system components, we have um, uh, we have PV modules. So convert sunlight to direct DC electricity. Monocrystalline silicon panels offer 20 to 30% of efficiency. So next is inverter. We know that DC to AC electricity, which converts DC to AC, is available as central string or micro inverters. And mounting structures. What are the mounting structures? The secure panels on roof or ground or optimal includes fixed tilt or single axis tracks. So balance of system. So BOS, balance of system is includes wiring, braking, monitoring, and safety equipments. So optimal, that is battery storage for energy independent or grid stability. So these components are work together for efficient capturing and converting solar energy. The optimal battery storage offers greater flexibility and range. Okay, this is what a core optimal energy. So next comes here, it is grid tied versus off grid tides. So grid tied versus off grid tides. Here grid tied, that is what on grid, and off grid is standalone tide. So connected to utility grid and most common. So net metering allows selling excess electricity, and no battery storage is typically required. And 95% plus of new PV installations. This is what an on grid systems. When off-grid is independent of utility. So independent of utility and requires battery bank for energy storage is important. Requires battery for this bank for energy storage, which is essential for remote location and emergency backup. So is an important for emergency backup. So power 1.2 billion people without grid accesses. So this is what an off-grid system. So the grid systems believe that from a grid backup and net metering, off-grid systems provide energy independent for remote areas. So this is the main difference between on-grid and off-grid. Okay. Now coming to major PV application segments, we have a major uh, three segment. One is residential rooftop. Next one is commercial and industrial. Third one is utility, scalar, and solar farm. So three major part. Okay, one is residential 4 to 15 kilowatts. So in commercial 50 kilowatts to 5 megawatts, and utilities uh, greater than 5 megawatts systems. So here we have an efficiency, and overall 60% efficiency is 15% efficiency. Here we have over 5.3 billion US homes has solar by and 2023. So these are the major applications. These segments carry out the diverse energy needs from individual homes to the large scale of power generations. Each offers unique benefits and development methods. So these are the main applications. Now coming to the innovations and nice PV applications. Here what happens here is building integrated photovoltaic cells and floating photovoltaic cells and aggregative photovoltaic cells. So building, floating and aggregative. These applications demonstrate PV versatile beyond the traditional ground or rooftop installations. They unlock new spaces for solar energy systems. Here we have seen the benefits and challenges. What are the benefits and challenges? Benefits is a zero emissions, decreasing carbon, then job creations. Here coming to the challenges, immediate requirement storage and grid balancing is a direct main challenges. Utility scalar projects and manage fluctuation power in the grids and initial investment. These are all the challenges. And finally, we have an uh, future of solar is a capacity growth. Sorry. We have capacity growth and cheaper electricity and technology advancement and global decarbonization. So these four are the main features of solar PV systems. I hope you enjoyed this video. We'll meet in next video. Thank you so much.